The Coast Protection Works at Chesil Cove, Portland. Consultation 2024. The following are my observations on the Dorset Council's draft proposals for Chesil Cove. They are based on a close study of the beach and coast protection works since the early 1960s. I have no wish to be confrontational. Everyone is seeking the best for the area. The slow eastward rollback of the main part of Chesil Beach does not apply along the built-up frontage of Chesil and West Weirs, where migration is arrested by the robust sea defence and coast protection features. No shingle is being lost from the beach, and it is not carried northwestward from the cove by littoral drift. Storm waves can denude the beach, taking pebbles offshore, but they always return. There is no net loss of beach material. Overall, the coast protection works present a sound defence to the shore of Chesil Cove. No part of the main structure is undermined, and the high end wall, with its deeply driven sheep piling, which extends as far as under the back of the promenade, means there is no possibility of the sea outflanking the wall, even in severe storms. Before 1964, the hillside above the cove was moving with retrogressive slumping. That was successfully addressed by the stabilisation, grading and groundwater drainage as part of the Coast Protection Works scheme. There has been very little movement and no significant new pressure ridges in the land between the promenade and the base of West Cliff in the last 60 years. The springs are intercepted by the land drains, and there is little evidence of continued mudsliding. The meandering walls of John Maine's land sculpture, the Chiswell Earthworks, were specifically designed with no mortar or concrete to allow for settlement. One of the things which wouldn't have been right would be solid masonry built walls with mortar and concrete foundations. That would have just added weight, would have not have helped the engineering solution for the area. But having these organic shapes with effectively dry stone wall constructions in a wavy form, it gave a flexibility to it and made it a very worthwhile addition to the land stability, actually, as well as being an artwork. And it's unusual these days to combine art with engineering, but here John has done it extremely successfully, in my view. As expected, the weight of the heavy stones has led to a few shallow cracks in the abutting ground, which are of no consequence. The protruding southern end of the seawall has not become more prominent or prone to wave attack than when constructed. The topography of the rocky shore has changed little, other than when mechanically interfered with in 2014, as described later. The distance between the wall and the big outer rocks is unchanged. The radius of the curved wave return wall was established to avoid presenting a flat face to prevailing waves. Being curved, waves hit it obliquely, so dissipating their force. Furthermore, the far end could not have been set further back without resulting in an exceptionally steep bank above, requiring the removal of several established huts. It would also have significantly increased costs. The curved mass concrete wall is in effect a massive horizontal arch which provides firm resistance to horizontal pressure from the retained land behind. No one segment can move seaward in isolation. The curved wave return wall remains completely intact and in its original position. It is not moved, nor is it rotating or breaking away. The two sets of steps are stable and the very substantial return and end walls remain as constructed. There are old cracks in the abutting step side walls at each end, which occurred soon after construction, due simply to the omission of movement expansion joints. The cracks have not widened significantly in 50 years. They are of no consequence and do not affect stability. The old crack in the far end parapet wall at the bottom of the steps has not changed since the 2011 block was added. The latter remains tight against the original structure, so it is not pulled away, despite it being undermined.
What covering of concrete are you going to have over the steel?
75mm.
Yeah, that was one of the things. It wasn't enough when we put it there. I think it was probably, well, it's nothing now, but it was originally I think about 50mm, but I think 75. Yeah, because that's a critical thing. That's not going to go anywhere though, hopefully.
That augmentation adds important mass to the southwest corner, and its steps should not be removed. It gives additional structural support and strength to that wave-battered corner, and will do more so once it is underpinned and extended. The side steps give important access to the beach corner and the rocks which people enjoy. The expansion construction joint gap behind the main wall at the southwest end has widened a little since construction, but the measurements also show that it actually narrows at times. This is a thermal joint and construction gap that has lost its flexible filling, and various factors can cause such gaps to change, including variations of temperature and moisture content. There are now signs that the abutting parapet wall alongside and parallel with the steps has moved. It is now slightly out of alignment with the back of the front wall. Conversely, there is no evidence that the main curved wall has rotated or moved forward at all. If it had, one or more of the construction joints between the front bays would be out of alignment, but they all remain flush with each other. If the end bays has rotated, that would be clear in the joints between them and the sloping rock revetment. Spirit level checks show no increase in the crossfall of the top face, which would be the case if it had rotated. No individual bay of the mass concrete wall could move in isolation, and there is no way that one end of the wall could behave differently to the other without obvious signs of distortion or displacement in the front and top faces. There is no evidence that pressure from the retained land is impacting the main wall. The assertion in the 2022 report that the seawall was failing prior to the augmentation works of 2011 is not correct. The seawall was not failing prior to the 2011 work. The original base landing and lower steps had been superficially eroded by storm battering, which did not compromise structural integrity. The 2011 work was designed to address the eroded state of the lower steps on each side of the original landing, which had become hazardous for users. The main steps, the parapet and the return walls had remained intact and were not undermined. The new steps, landing and parapet at the bottom were specifically built to provide safer access to the shore, and that's a reference to Black and Veatch condition report of December 2009. That additional augmentation block is the only part of the entire seawall that has been undermined, which can be easily remedied by underpinning. That was exacerbated in March 2014 by the removal by machine of many rocks that were protecting the front of the wall, fronting the southern steps. Removing those protective rocks was a mistake, as that exposed the corner to more severe wave battering and led to its undermining. The removed stones were taken to bolster the eroded bank beyond the far end. Instead, Portland stone blocks should have been imported for that unstable bank, which supports the footpath along the weirs. The original steel piling fronting the far end steps and under the 7-metre high return wall is deeply buried in very firm ground and is not undermined nor exposed to corrosion or erosion. The wall at the southern end has not lost the support of the beach and clay. The beach does not support the structure. It protects it from scour. The 3-metre wide reinforced base slab behind the piles is reinforced by steel pile counterforts and cannot be moved or damaged other than by some implausible catastrophic event. There is no overall foreshore lowering. The beach levels fronting the wall have always fluctuated dramatically. Occasional storms denuded the beach of shingle, exposing sand and the clay substrate. The exposed clay is hard and slippery. It is never exposed for very long, so any erosion of it would be minimal and slow. The average shingle level fronting the wall has remained fairly constant over the years. The boreholes are through the formerly unstable and sliding clay slope, and the inclinometers show small movements. Such movement cannot be translated to any movement of the rigid wall itself at the bottom of the slope. There is no evidence that any ground movement is causing undue displacement or pressure on the back of the wall or down at the beach level where no boreholes were drilled. The compacted fill is capable of absorbing limited movement as it is not a solid mass. The ancient shear planes revealed in the boreholes are so far below the promenade and wall that nothing can be done about them. The degree of slippage recorded in the boreholes is minimal anyway, so should not be of concern. During construction in 1964-65, a distinct slip plane was identified over the entire length of the excavation for the main wall. This was verified by the local engineers and by eminent civil engineer Dr. Edwin Gifford of EWH Gifford and Partners Consulting Engineers. Accordingly, the foundation of the reinforced concrete base slab under each bay was bedded well below the sliding ground into the very firm underlying clay. It appears this shallower slip plane was not identified in the recent boreholes, but the latter were some distance from the concrete wall. The sloping rock revetment shows little sign of movement or settlement and remains much as it was when created in 1965. This and the promenade rest on imported stone fill overlaying the mass of previously unstable clay. There is no possibility of any of that underlying material migrating through or under the sea wall. There is simply no way through or past that solid structure and the sheet pile curtain. There is a shallow settlement towards the centre of the promenade and in the reinforced concrete curb abutting it. This occurred several years ago and was previously identified as being caused by the breakdown of one of the land drains immediately behind the back retaining wall. A small section of the bank had slumped and water had washed down some fines, causing the dip in the promenade. This is a very localised issue. The dwarf retaining wall at the back of the promenade has some cracking and displacement at the far end due to a spring in the bank immediately behind, making the ground spongy and unstable. The land drain there may be leaking. That should be checked and dealt with. I am concerned that the cast iron groundwater outlet pipe at the bottom of the steps is no longer discharging as it should be, indicating a possible break in the pipe at the top where there is a manhole. That is a local issue with no impact on the main structure. There is little evidence that wave energy has increased in Chesil Cove. Rising sea levels have been mentioned, A rise of a few millimetres per year, if that, will not impact on this existing wall for decades, if ever. Whether or not storm power has intensified or increased in frequency, the Chesil Sea Defences and Coast Protection Works should cope with that. There is no evidence that the seawall suffers from increasingly large impact or drawdown forces. The severe storms of 2014 were exceptional. The edge beam that doubles as pile capping should be repaired. Over a short length, the beam is badly corroded, with its reinforcement exposed. The steel piles there are badly corroded. This has progressively worsened since first exposed before 1970, as evidence in the photographs. This should be encased with shuttered concrete, extending the 2011 work. It would deflect waves while forming good protection to the base. In the interim, the exposed steel piles and edge beam should be sealed and protected, possibly by applied concrete such as gunite or shotcrete. This is urgent. Flexible filling should be reapplied to seal all the joints in the main wall, and the old cracks in the wing walls should be repaired. The comprehensive geological investigations for the Priory Corner diversion scheme at the top in the 1990s fully described the processes at work there. That scheme successfully secured the A354 for the long-term future. The road was rerouted well away from the potentially unstable cliff in 1996. The settlement, toppling and fissures in that area are caused by natural geological processes in the Portland stone beds. Holes have occurred for many years where finer material gets washed into voids in the loose ground. Those voids are not getting worse or becoming more frequent. As long as the coast protection works at Chesil Cove remain intact, there is no threat to the A354 or to any properties. Nothing occurring in the Priory Corner area relates to any movement emanating from the weirs directly below or from the sea wall. Clay on the seabed off the cove shore is described as landslide debris deriving from the great 1858 landslide. It is probable that much of this will be the hundreds of tons of excavated Kimmeridge clay that was deliberately allowed to be washed from the beach in the Coast Protection Works schemes from 1959 to 1965. That material was spread by wave action over the nearshore seabed. That may have been mistaken for the low-bait debris from the 1858 landslide. Survey maps from soon after the 1858 event do not indicate anything beyond the shoreline. So the slipped material from that landslide must have quickly dispersed after the event. The water lines in the cove changed little through the 20th century. The destruction of any part of the natural corner of Chesil Beach would be a disastrous loss to Portlanders and to visitors, who have enjoyed this special spot for countless generations. To cover any of the beach there with boulders, whether granite or Portland stone, and to deprive the public of access to the beach and rock pools from the southern steps is simply not acceptable. There are existing rocks on the frontage, which are sometimes exposed at low shingle levels, which are buried when the pebbles return. It is most unlikely that the proposed imported boulders would ever become covered by pebbles, given their size and quantity. They would remain a hideous alien disfigurement to this corner of the heritage coast. In conclusion, the seawall and stabilised hinterland remain stable and robust, showing little evidence of serious movement or material damage other than at the exposed piling and edge beam and the undermined augmentation block of 2011. That should be repaired and protected without further delay. Overall, There has been minimal change since the Black and Veatch condition assessment reports of 2009 and 2010.